Okay, so let's look at this nice video made by NASA. And where is my website? There it is. Oops. So this is the animation uh, called Perpetual Ocean. It's very loud in my head, but I think on the video it's not that loud, so I'm going to speak over it. But you can see everything we talked about: the North Brazil current, shedding rings, becoming Antilles current, Caribbean current, Gulf Stream, the South Equatorial, North Equatorial currents, the thermohaline circulation coming in here as a Gullus eddy, going off as a retroflexion, and rings into the so-called Agulhas rings, supplying the Atlantic meridional overturning circulation, the complicated Indian Ocean circulation, western boundary splitting into these little eddies based on the season, the changing the currents changing direction, and so on and so forth. The ocean is actually full of eddies. It's not always clear what they actually do. It's kind of the leaves moving all the time. They are part of the ultimate dissipation process, I'm sure, but in the ocean we don't know whether they contribute to the heat transport as a part of the equatorial to polar energy transport or not. But you can see that every current that when you averaged over a long time produces these structures that we looked at, like the North Equatorial countercurrent, the South Equatorial current, equatorial currents, and so on. But every system is non-linear, so they all split into these eddies. And the Southern Ocean Antarctic circumpolar current is particularly full of eddies. Okay, so you can see that very nicely here. So any strong current is going to become unstable and split into eddies. When you average over a long time, you're going to get the currents that we defined before. So those currents do exist, but when you look at snapshots or a particular minute or particular hour, it's going to be full of eddies. Okay, these eddies are very important for transporting things, for biology, for chemistry, for AFC exchange, and so on. But this is a simulation made by running a very high resolution computer model and inserting data into it. If the model is allowed to run by itself, it will not be as realistic as you would want, because models have errors, there are numerical assumptions, there are errors in the fluxes in the winds and so on, and the mixing in the ocean, etc. But when you insert data into it, they become much more realistic. So you can go Google Perpetual Ocean, and this video comes up, and you can look at it again and again. It's just good to look at. But it does tell you a lot about how the real ocean works. There are similar videos for ocean color, which shows how biology acts as a tracer. So everywhere where you see rings, often there is chlorophyll associated with it. So you can see these nice features in ocean chlorophyll as well. You can also see it in clouds, in moisture, and so on from satellite data. I will show one later on. Okay. That concludes this chapter on ocean circulation. Lots of concepts, but we also combine the concepts to produce bigger pictures like El Nino and La Nina and so on. So we will add biology to it, we will add waves to it, and so on. So you must keep track of all the concepts and be able to synthesize them when necessary.